Okay, welcome back. We're still talking about functions. So if you remember, a function is a type of relationship. So if we do our function Venn diagram, here's a function. There's a relation. That's bad drawing. Pretty much what I need to say for that is all functions are relations. But not all relations are functions. So for every value in the domain, there's a unique value in the range if we think about it. So that could be said as only one range or y value for each domain or x value. Okay. You can think of a function as a machine. We have our little function machine here, and to every machine you need to put something in. I take my toaster. I put in, my input is toast, or my input is bread. Well, let's say I take my toaster oven. It's my function. My toaster oven is my function machine. Okay, I input bread. I output toast. If I input bread, I'm not going to get out scrambled eggs. It's not possible. So let's think of a function as a toaster. Let's say a toaster is a function. Let's look at my input or my x's and my output. If I input bread, I get toast. A function has to be something that gives a specific thing. So, toaster oven. If I put in my lunch, I'm going to get warm lunch. If I put in bread, for it to be a function, I can't get scrambled eggs. If I get that, it's not a function. This is invalid. An invalid output. It can't be true. So I would cross that out. No, I can't do that. So let's look at that in terms of numbers. Let's make a chart, x and y. X and y, 0, 1, and 2. Well, 0, I put it into my machine, I get a 1. I put 1 into my machine, I get a 2. I put a 2 into my machine, I get a 3. This is a function. Yay, it does what we want. Let's compare it to this, x and y. Okay, let's say I put 0 in, I get 1. I put 0 in again, I get 2. Okay, I'm going to try again. Let's put 0 in. I get 3. Now in this case, my domain is not producing a single range. my x value is producing multiple y values, not a function. Doesn't even warrant a full sentence. Okay, let's do a vertical line test. Let's talk about the vertical line test. The vertical line test. The vertical line test states that a straight vertical line will not pass through a straight vertical line will not pass through a function more than one time. A straight vertical line will not pass through a function more than one time. More than one time could be 0 or 1. It could pass through not at all, and that could be an example if you have limited domains and ranges. Say I'm only graphing something between 0 and x equals 0 and x equals 5. If I check at x equals minus 1, of course there's not going to be anything. That would be similar to me doing a test where I say, like, okay, you can only take your test in the Learning Commons. And I go and I check, and you're not in the Learning Commons? What does that tell me? Well, it tells me you're not taking the test because you're not in the Learning Commons. Okay, just give me a moment here. I'm just drawing 4 different things. What I want you to do is draw 4 sets of axes like this. And I'm going to stop for a sec and I'm going to draw what I want us to draw. Okay? Okay, and we're back, and we're pretending that circle is perfect. So, I have drawn us this line, that line, and these lines. And what we're going to do is we're going to apply the vertical line test to determine if they are functions or not. So I want you to take a moment and think about the vertical line definition. A straight vertical line will not pass through a function more than one time. So if it's something that passes through a function more than one time, it's not a function. Okay, so I want you to take a second and I want you to try to graph those, and we'll come back together in a moment and graph them ourselves. And by graph, I mean check the vertical line test. All right, so if you haven't, go through and try it out now. Pause your video, draw your things, do that. But I'm going to continue and see if it's a vertical line test. So the vertical line test is a straight vertical line will not pass through a function more than one time. So that means it's only going to pass through a function not at all due to domain and range constraints, domain constraints I should say, or it's going to pass through one time. If it passes through one time more than once, it's a relation, it's not a function. Let's check this one. Let's check A. Okay, A. Vertical line. I'm going to take my pen, I'm going to sketch a vertical line, in a few different places. Alright, I've sketched it. Every place I've sketched it, it passes only one time. One intersection here, one intersection here, one intersection here. I have 3 different x values. This passes the vertical line test. This is a function. Okay, let's look at B, the circle. Okay, this circle. Now, I could start all the way out here like -4, and I could do my vertical line test. And I do it. Awesome, it doesn't pass through more than one time. It doesn't pass through at all. You need to go find somewhere where it's going to go through your graphed portion. I'm going to Pick anywhere along here, and look, as I slide through, hopefully what you're noticing is that it's a circle, as much of a representation as I can make a circle, but as I graph this, and as I do a vertical line test, it intersects here and here, and it does that all throughout. And yes, I guess technically if you go to the minusculest edge, it looks like it's only passing through one time. But we're not going to get into that. We're going to get into, like, if you go dead through the center, it's only going to pass through twice. This is not a function. Not a function. Let's go down to the next line. C. We've got a vertical S. Now, here, I don't know. Here, I don't know. But anywhere along that plotted line, plotted curve, I draw, oh my goodness, how can I not even follow a straight edge? This is vertical, we're pretending this is vertical, and for all intents and purposes it is vertical even though it's not. 1, 2, 3, I get 4 points of intersection. Is that more than one? Yes. So this is going to be not a function. Okay, last one, vertical line test. Okay, from all points here and over, my graph doesn't exist, and all points here and over, my graph doesn't exist, or what I've plotted. I'm only going to focus between these and inside. And if I even just trace my straight edge along, I am seeing it's just a roller coaster, ups and downs, and ups and downs, and down and down and down, and oh no, it stopped. So no matter where I place this line, I am only intersecting my plotted line one time. This is a function. So vertical line test. Drop a straight line through it. If it goes through more than once, it is not a function. It is a relation. All right, on to the next page. Change my pen, put that one back, put that one back, put my compass back. Okay, we are still clocking with the 21st of May, 2020, FMPC10, page 2. What's page 2 going to take us? No one knows. That's a reality. No one knows. Let's take a step back and let's look at this that table we gave you. Let's take a step back and look at the thing that was not a function. Okay. Actually, let's look at this table, x and y. I plotted this earlier. 0, 0, 1, 1, 2, 2, 3. If I was to graph this, and we're just going to freehand sketch this and see if it looks like a function or not. X, y, 0, 1, 2, 1, 2, 3. Well, 0 is 1, 1 is 2, 2 is 3. And I draw a line, assuming everything's plotted very perfectly, which we all know with gaffing is not. These are just sample sets of values. I see this passes the vertical line test. I follow this across, it only is intersecting each point of the line. So this passes the vertical line test, we'd establish it's a function. Okay, not a function example. This is where I had my x's being zeros and my y's being 1, 2, and 3. Let's quickly graph this. We're going to freehand this. Bada bing. I should have chose different values. In this case, we're going to pretend these are all 2's. So 0, 1, 2, 1, 2, 3, y-axis, x-axis. Okay, I only did this because we wouldn't see what I'm trying to show you. All right, 2 and 1 right here. 2 and 2 right here. 2 and 3. This does not pass the vertical line test. If I do my vertical line in red ink, we will still be able to see. It passes through all those dots at one time. This is not a function, so we can see how it fails the vertical line test. So it's not a function. We've gone over what a function looks like the last 2 lectures. So what we can now continue to do is look at function notation. There's a special way to write functions. And function notation is a symbolic notation for writing read my notes for a second there. Symbolic notation for writing a function. So we could have an example function of the function, and we could say, hey, it's a function. We could call it that every time. The function y equals 3x plus 1. So we're saying the function at the output is equal to the input times 3 plus 1. But this would get cumbersome, and this could be interpreted as, well, y is the output, x is the input, and we could say the function in words, the function this would translate to the output is equal to 3 times the input plus 1. Okay. And I'd have to say the function y equals this every single time, and I don't want to do that. I want to simplify it. I want to simplify it by saying f of x is equal to 3x plus 1. It looks different, but it's telling me the same thing. Well, the function of x is to make an output, right? The function of the machine is to get your output. I don't call it my warming bread machine. I call it my toaster. I call it what it's going to be an output of. So this is the name of the function. I can call my function any letter I want. I'm going to stick to f just to keep it simple for now. This is the name of the function. I could call my function Bruce. That would just be long to write and really frustrating and annoying. So you have your name of your function, f. The parentheses tell you where the output is. And this is your variable. The parentheses tell you where your input is. The variable is your input. So I go back to my toaster oven example. I can change what I'm putting in there. I could cook my French fries in there. I could bake a potato in there. I could warm a bagel in there. I could make toast in there. I could reheat my lunch in there. I could roast a very, very tiny chicken. Cornish game hen maybe. These are all inputs into my toaster oven. I cannot cook my Thanksgiving turkey in my toaster oven. This is where there's usually limits in a function machine. In this case, my function machine is limited by size. Okay. And then the function x, the function of x, and you read this as the function of x. And here is my output, or my y. So you could look at this as being read the number x is put into the function machine, and I'm just loosely calling it a machine because to equal the output of 3x plus 1. Okay. Let's just give a few examples of different ways to represent it. I don't know if I like this next part of my notes. Just a moment. All right, I should have headed this already. Okay. To recap a function, it is not a function if one x or input goes to many y or output. Okay, I'm going to stop it again. I'm going to draw a few things and then we're going to do a quick little activity. Okay, welcome back. So I have drawn 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 relations. They're not all functions, but some are. What I want you to do is I want you to go through and I want you to find the functions and I want you to circle them. You can just circle a letter or whatever. Go through, do that, and then we're going to go through and review it. So take a few minutes, pause your video, and work on that. All right. Let's take a look and we will circle the functions. So remember, for a function, it is not a function if one x goes to many y. Let's take a look here. In this case, I have an x going 5 to a 10, 6 to a 15, 7 to a 20. In this case, each x is only going to one y. This is a function. Vertical line test with a graph. It passes more than one time. It is not a function. Vertical line test. That should be a straight line. We're pretending it is. Not a function. D, vertical line test. Now this is an inverted parabola, and as you go through, these are going to continue into ever out extending, and no point throughout it does it intersect more than one time. D is a function. E is a straight line. Go follow through. This is a function. F, wrong, not a function. Now we're back to G. G, well, I have saying that my input of 3 is giving me 11. I'm also saying my input of 3 is giving me 21, and my input of 3 is giving me 31. Machines don't function like that. My hammer can drive nails. My hammer doesn't do a good job when I ask it to mix soup or write my notes. This is not a function. H, oh man, why'd you do set notation, Gaffney? This is ridiculous. Well, let's take a look. 10 produces 10. 12 produces 10. Well, wait, same Y's. Oh, but they're different X's. Yeah, sometimes I can use a hammer to drive a nail. I could use a sledgehammer. Different machine, same output. Here, 14 and 12, 16 and 12. Well, I could use my drill to screw in a screw. I could use my screwdriver to screw in a screw. This is a function. Okay. Right. 8 and 3. Okay. 8 and 5. 8 and 8. So this is saying that my screwdriver can write my notes, screw in a screw, and pound a nail. This is not a function. Okay. Again, down here, number J, letter J. 11 makes 3, 12 makes 3, 13 makes 3. I can use different machines to get the same type of thing. I could write my notes in pen. I could write my notes in pencil. I could write my notes in crayon. This is a function. K. Immediately I see duplicate X's. My duplicate X tells me that I do not have a function. Circle. Bam. Immediately you see a circle, that's not a function. It's a relation. M. Well, 10 can go to 10. Yeah. 12 can go to 10. 12 can go to 14, and 12 can go to... No, that doesn't work that way. That's not a function. This hyperbolic curve, curve. This is continuing, inching closer and closer, never really getting to wherever its edge point is. Because of infinity, this is a function. So I've circled the following functions. 2 straight lines, this is a function. Hopefully that gives you a bit of an idea how to make functions. I will give you a few examples to work on that for homework, but we're going to continue giving some more notes. One more page. I've decided one more page of notes, because functions are machines. Functions give you an input. Functions give you an output. FMPC10, 21st of May, 2020, page 4, working with functions. All right, sorry, we're working with functions. I just got my phone rang. That's the function. That's one of its functions. It was Service Canada telling me I had outstanding warrants and problems, but they hung up on me when I tried to talk to them. I hope I'm not going to get arrested. All right, anyway, working with functions. Let's talk about my toaster. So, my toaster oven. Well, I can say that my toaster oven, the function of my toaster oven is my function is my toaster oven, my input is X, my output is warm X. Okay, that would look like something like this. I put in bread, I get warm bread. I should have phrased that differently. Alright, so let's say I take my toaster oven and I put in pizza, a slice of pizza. My lunch, leftover pizza, take it out of the fridge, put it in the toaster oven, I get warm pizza. That's my work with functions. Now we can do the same thing with numbers. So, let's say I have a function of x. And I'm going to use my 3x plus 1 example. So, what my function of x is it gives me an output. So, for all real numbers, let's say. Oops. So I want to say for all so I'd say that x such that the set of x is an element of all real numbers. And y such that y is an element of all real numbers. So I'm not limiting how far I can go. I can go all numbers, any number, whatever number I want. Okay. So that means I can take my x, my input. I can pick any inputs I want. And I'm going to get my output, which is my f of x, equals 3x plus 1. Let's keep it simple. Let's pick nice, small, easy to work with numbers, things that you can probably do in your head. I'm going to pick 4 of them. Okay. F of x, 3x plus 1. So what you do is you take your x and you plug it in. X is 0, you put 0 in. What's 3 times 0? Well, let's do side work over here. Let me do it this way. Okay, so when x equals 0, let's say I want f of 0. Well, I'm going to take my 3 times 0 plus 1, and I'm going to evaluate it. So my function of 0 is equal to 3 times 0 plus 1, or 1. I'm going to put that in there. I'm going to do the same thing for f of 1. F of 1 equals 3 times 1 plus 1. Well, that's the same as saying 3 plus 1, or 4. We'll put a 4 in there. Let's try f of 2. Working with functions, taking that number, my function of x is equal to 3x plus 1. And I have to evaluate. I have to put that input in the machine and see what I get. So my machine is 3x plus 1, 3 times 2 plus 1. My machine is going to plug away using order of operations. Well, first 3 times 2 is 6, plus 1, 7. Okay, I'm going to take my input. Okay, 3. I'm putting 3 in my machine. Okay. Inside my machine, 3 is multiplied by 3 and added to 1. Well, 3 times 3 is 9. 9 plus 1 is 10. And I get a final output of 10. I would stop there. Is my output finished here? No. I can still do some work on that. Is my output finished here? No. I can still do some work on that. Here my output is finished. There's no more operations to perform. Let's throw 4 in the machine. Let me see. A function of 4. Okay. 4. I put 4 in the machine. Well, 4 is multiplied by 3. And added to 1. All right. Am I done here? No. I have an operation of multiplication. I can multiply it. 12 plus 1. Am I done yet? No. My machine still has some processing to do. It's like checking to see, is my bread nice and browned yet? No, not yet. I keep going. This is 13. That would be an example. Let's say I have and you would just keep doing this. What could be another example I could have? Let's say I have a function of x, and just remember, the function can be any letter, and the variable can be any variable. It doesn't matter. It all depends on what you're working with. X plus 3. Okay. I want you to find the function of x when x equals 1, 2, and 4. Well, what you do is you'd set it up. Well, the function of 1 is 1 plus 3. Do your operations, machine work, 4. What's my input of 2? Okay, I put 2 in the machine, I get 2 plus 3. I get an output of 5. F of 4. 4 in the machine, well, it's 4 plus 3. Okay, it's just straightforward calculations. Now let's say, let's do another piece. Now sometimes you have a machine, you see the machine, you see what's sitting outside of it, but you don't know what made it. So let's say you do. You go to a factory and you see a thingamajigger sitting outside at the output of a machine. And you see the machine and you see where you got to put stuff in, but there's 3 different boxes and you don't know which one produces the thingamajigger. So you would have to back calculate. In math, you can do this. 21 February. No, May. Oh man, 2020. Okay, so let's say you have a machine, you have a function of x such that 5 times x plus 12 is the machine. There's my machine. Okay, bam, there's my machine, 5x plus 12. And I know that if I have x equals 1, that's f of 1 equals 5 times 1 plus 12. Well, that's 6 plus 12. That's 18. Okay, awesome. I put 1 in. I get 18. What happens if I put 2 in to the machine? There we go. Put 2 in. Machine starts working. I get 10 plus 12. Awesome. What if I put 10 into the machine? Function of 10. Okay. This is kind of like your instruction. Like, oh, okay, I'm doing a function on 10. 5 times 10 plus 12. Well, 5 times 10 is 50, plus 12 is 62. Awesome. Now, you've done this, you know what your machine can do, you've run through a few things, but over here, you've got this thing, be like, hey, I want to get out, let's say I have a function of x, this is continued, that's something is equal 112. And I know that my f of x of my 5x plus 12 made f of x equals 112. I know somehow I got to 112, but what do I do? What do I need to use as my input? So, list what you know. List what you know. You know your machine f of x equals 5x plus 12. And you know that one of your x's gives you 112. What's this equal to? F of x. What's this equal to? F of x. Well, we can say f of x equals f of x, or we could say that, well, 5x plus 12 equals 112. And you can solve that algebraically. Simplify. X is equal to 20. There we go. If I put 20 into my machine, I should get 112. Let's check that out. Let's do a check. Well, I know 5 times 20 is 100, plus 12. It checks. Awesome. I can also back calculate for my machine to see what I get. All right, I'm going to stop there. I'm going to work on processing this, get it all posted, get these notes posted. I will send you an assignment. Have a wonderful day. Talk to you all soon. Goodbye.